All right, this is part 2 of how life came to exist on the surface of the Earth. All right, we're talking about how the atmosphere changed. Well, the atmosphere was critical because humans, or any animals, we all use oxygen and release carbon dioxide. So, for higher forms of life to exist, we had to have the point where we had enough oxygen in our atmosphere. We only got enough oxygen in our atmosphere about 550, 600 million years ago, and then all of a sudden, boom, we see life exploding all over the place. In the oceans, on the land, everywhere. And then we get into the point where we have the different extinction events, which we have been talking about. All right, this is how our atmosphere changed in a graph form. So you see, this is years ago. So this is 4.6 billion years ago when the solar system formed. Remember, there was hydrogen and helium around because that's what makes up most of the universe. But that didn't last. Our Earth is not large enough to hold on to its hydrogen and helium. It just escapes into space and we can't hold on to it. The water vapor came around because the Earth was so hot, any water that existed at all was completely in a gaseous form. And so our atmosphere contained lots of water vapor. The ammonia and methane, those were also common elements just floating around from the original solar system cloud, the gas that was there. Notice the ammonia and methane actually get destroyed over time through chemical reactions. The ammonia and the methane, which are carbon and hydrogen in different combinations. Ammonia is actually nitrogen and hydrogen, NH3. Methane is CH4. So they get recombined and you end up with carbon dioxide, and you see the carbon dioxide jumping way up. This is when the carbon dioxide was very high, okay? Nitrogen started coming up because once the nitrogen is released, it doesn't react with anything, so we just have nitrogen. And then the carbon dioxide gets used by the plants and converted into oxygen. You see, it's about this point way back here, right about in here. In fact, they call it the Phanerozoic era, when we have enough oxygen that we can have higher forms of life. That's why you also try to find life around planets that we know are around stars that have been around for at least 4 or 5 billion years, because it takes that long for a planet to change into an atmosphere like one that we can exist in. So if you look at a star that's only a few 100 million years or less than 1 billion years old, finding life there is probably not as likely. Same thing here. This just shows just the oxygen. And you see oxygen started forming here, but it wasn't until we hit right about here that oxygen took off enough that we could have higher forms of life. And the oxygen percentage has been changing over time, and right now we're hitting at about 20% oxygen. Rest of it is mostly nitrogen, and then the 1% of the other stuff. All right, so let's talk about life on Earth. How does it come from? Where does it go? One of the most interesting experiments was what's called the Miller-Urey experiment in 1952. And if you're interested in this, you should go look up the experiment. But what they did is they said, hey, maybe we can create the same conditions that exist in the early solar system. So in this tank right here, they put the same gases, the ammonia, the methane, water, hydrogen, all those things that would have been early in our atmosphere. And then they said, well, we need something to make reactions occur. And we know that early on there was lightning, thunderstorms, just like we have now. And so they created sparks. Well, those sparks, that electrical energy you add to it, then changes the composition. It makes chemical changes occur to all this stuff. So they did this, they ran it for a while, and then they looked at it, and what did they find? They found amino acids. What are amino acids? Those are the things that build proteins, which are the molecules that build life. So what they did is they didn't create life, but they created the molecules necessary for life to create by just creating the same kind of atmosphere that the Earth had early on. Now what's interesting is the experiment was done in 1952. Well, then they put the experiment in some back room and just left it. But all the material they created was still there. Well, they reanalyzed that same material in 2008, 2010 when we have a lot better equipment, and they found that there were even more amino acids than Miller and Urey found. That it was creating way more than they even thought they did then. They just didn't have good enough tests to find out back then. So we know if you get the right conditions, you're going to create the right kind of molecules. Does that mean it's life? No, and nobody knows exactly how you really create that spark of life. But you got the right materials to make it happen. So, if there's life like that, if a planet has life, how would we find it? And so let's think about that. From a scientific point of view, all we get from any other star is light. And if all we get is light, we have to be able to analyze the light to try to understand if there was life around the planet. So first we have to find the planet, then we have to be able to see its atmosphere, and then we'd have to try to understand what is in its atmosphere, and if what is in its atmosphere can tell us if there's life there. Because we know that life changes the atmosphere of the planet. So these are the things we're going to look for here. So what happens is the planet, right now, most of the planets we found are found because they pass in front of their star, and we can see the star dimming because the planet passes in front of it. Well, some of the light from that star goes through the atmosphere of that planet and comes to the Earth. And so as the light passes through, we can analyze that light and look for signatures of different molecules. And the molecules that we're looking for are things like this. All right, this is methane. Water, now water is common, so that doesn't tell us anything, okay? Oxygen would tell us for sure that we're in good shape, because oxygen, O2, can be created through chemical reactions, but it's not in abundance. You really can only create O2 through some kind of organic matter creating it, some kind of life that creates it. Because oxygen is so reactive, it usually reacts with carbon or something else, or hydrogen, or becomes tied up otherwise, so you don't see O2 by itself unless there's some process making O2. So seeing O2 is a good sign that there's life there. Okay? Ammonia is a possibility because ammonia, as I told before, normally gets destroyed in our atmosphere over time. Because of reactions, the CH4 reacts, the hydrogen recombines with oxygen, the carbon combines with oxygen, and you end up with water and carbon dioxide, and the methane doesn't stay around very long. But if you're seeing live methane, it usually means there's something that's producing the methane. Methane is produced usually by animals or by decaying plant matter or something of that type. That's one of our challenges now, is methane is a greenhouse gas. And a lot of methane was tied up, especially in the Arctic regions around like Alaska, in the permafrost, and it was just frozen in there. But now with global warming, the Earth is getting warmer. Some of those permafrost places are all melting, and it's releasing more methane into the atmosphere, and that methane in the atmosphere then makes the greenhouse even go more. So it's a problem that we have, is too much methane in our atmosphere. All right, so those are the kind of signatures we look for around another planet, or that was what we'd hope to find to give us an idea that there might be actual life on those planets. So far we haven't found any, but so far it's been really hard. We're just at the stage where we're just starting to find planets. We're not at the stage where we're actually searching for life in detail. Now, some people say, well, that's how we look for life as we know it. That's life on Earth, all right? Our kind of life, which is based on carbon molecules, water, all that. How do we look for life like we don't know? Well, that's hard to tell because you don't really know what to look for. But the more we look on Earth, we're finding life that's based completely differently than the life that we normally think of. There's even microbes that live down deep in the crust of the Earth, like 4 or 5 kilometers down, that eat rocks and expel rocks. And that's it. They don't have anything to do with sunlight or anything else. There are certain types of life that live around the sulfur vents coming out in the bottom of the ocean, living off all the chemicals coming out from the mantle of the Earth. And they have nothing to do with the solar cycle and carbon or anything else. So there is other ways to make life. So yeah, our problem is it's hard to search for life like we don't know it, but it may be possible. All right, that's it for this part.